Hello, chemistry students. We're going to be talking about molarity today, and molarity is defined as, this molarity right here, it's defined as the number of moles of solute, divided by the number of liters of solution, and it's a way to calculate, how concentrated or how dilute a solution is. Chemists can easily look at any solution and see what the molarity is. And so if we had a solution that we would say that's 2 molar, which is read as 2 molar or a molarity of 2, that solution would be more concentrated than a solution of, let's say, 0.1 molar. And so it'll immediately tell a chemist whether or not to treat a solution with a little bit more respect. They can tell how concentrated it is, how many moles, like I said, of solute are in a liter of solution. So let's get right to it and dive into a problem involving molarity. We oftentimes take this molarity formula and we write it, molarity equals moles per liter. And so let's look at this problem and see if we can analyze and see what's going on here. So it says calculate the molarity of a solution that is made by dissolving 2.5 moles of sodium chloride in enough solution to make 0.75 liters. And so what we're going to do is we're identifying some of our given values. And so our first given value is 2.5 moles, and our second given value is 0.75 liters there. And so what we're going to do is we're going to plug these values into this formula. So we have 2.5 moles divided by 0.75 liters. And all those units match the molarity formula equation, and so we should be okay. So we're going to divide 2.5 by 0.75. Okay, and so that gives me an answer of 3.3. It gave me a whole bunch more sig figs, but I'm going to round it off. I have 2 sig figs as my moles and 2 sig figs as my liters. And the unit that's going to go along with this, I could write moles per liter, which would be a perfectly acceptable unit. We could also write the unit of 3.3 molarity or a molar solution. Either one of these is perfectly acceptable and the correct answer. Okay, let's go down and take a look at another problem here. And it's, again, we're going to use the molarity formula. Molarity equals moles per liter. And let's take a look here. It says how many moles of potassium iodide, Ki, is required to make 500 mils, highlight 500 milliliters there, of a 0.0250 molar solution. Okay, so we have some values that we can plug directly into this formula. First off, we have this 0.250 molar. So I have 0.250 molar solution there. I also have 500 milliliters. Now, we notice that the unit here is milliliters, but the unit we need down here is liters. And so what we're going to do is we're going to convert this. 1 liter is equal to 1,000 milliliters. So basically what we're going to do is we're going to divide 500 milliliters by 1,000, or we can convert it by moving the decimal. The decimal's right here. We can move it 1, 2, 3 places to the left, which is the same as dividing it by 1,000. And so I'm going to get an answer of 0.5 liters. I have to remember to convert milliliters to liters. And a very common mistake is students forget that they forget to convert milliliters to liters. They just punch milliliters right into the molarity formula and they come out with this answer that doesn't seem right, and it won't be right. Okay, so now we have 2 of the 3 variables that we need, and all we need to do is we're going to solve this equation. We're going to solve it for moles. And so we're going to multiply both sides by 0.5 liters. And that's 0.5 over there. There we go. And 0.5 liters is going to cancel on this, so algebraically we solve it. So we're going to take 0.5 and we're going to multiply it by 0.25, and we're going to get an answer of 0.13 or 125. We'll round off to 2 sig figs here. And looking at the unit, because we were solving for moles, this answer is going to be moles of potassium iodide. And that's how we can solve a molarity problem.